everyone. It's so nice to see you guys again in person. How are you guys doing today? Good. Did you have a good day? Great. Were you guys able to log into your website? Most of you did, right? So remember that 2 weeks trial period already started. So even if you did not sign in, you're missing your 2 weeks trial period. So you should, if you did not log in, if you did not register for this course yet, you should at least do some homework if you don't intend to buy it. Something is better than nothing, right? And you should buy at least 20% of the rate. So if you desire especially A, B, or A minus, B minus, you definitely need it. But if you're happy with your C or D, then you're fine.
Thank you for all the work. It'll be anything else think about F24. So
Don't let me add anything else. Whatever you have, you can make it.
yes, it's kind of steep
Whatever you can, no problem.
Got 6 done.
No problem. If you already know your materials from before, I don't mind if you cram everything into these. Actually, people did before. And I know it's expensive, so I don't mind. And I was talking to the department actually once. It's too expensive for the students. And they said, don't ever talk to them about the price. Just tell them to buy it, and that's it. But I simply saw yeah, like I said, we are just representative of the department. We actually have not much power to make any change to anything about any of the department, unless you are one of the coordinator. So we are not coordinator, we are just instructors. But I try my best to make my students' life as easy as possible. But you also have to do your job. Okay? So, oh, I forgot to post the review sheet. I'm going to post the review sheet, and then your exam will be beginning of next month, if I'm not wrong. And I noticed that next month we have actually many off days. Did you notice that? Like October 2, 4, and then 11, 12, 13, 14. All of these we have school closed. So, yeah. Since our class is only 1 hour 15 minutes, so even though I want to go very slow, but I actually cannot go, sometimes I just have to speed up with the materials. If you find anything not understandable, not clear, always ask me question. I will try to clarify your confusion here. And if it doesn't help, we have YouTube. Start YouTube with any topics, and then you'll see many videos. At least one of them will be helpful. That's how actually I learn. Whatever I don't understand in my classes, I search on YouTube, and then I keep watching many videos. And one of them is definitely helpful. And then I try to stick with that instructor, that lecturer, that YouTuber to get all of my topics done. You can do the same. Any question before you start? Comments? Complaint? Concern? Nothing? Okay, so we are done with chapter 1, 2, 3, and this is chapter 4. In our last class we started and we talked about mean, median, and mode. So mean is the average, right? What is median? It's the middle number. And if you have odd number of data set, how do you find the median? Take the average. If you have even number. If you have even number of data set, then at the end you have 2 medial number, so you take the average of the 2. But if you have odd many data sets, then you just cross out everything else from the left and right. Whatever remains in the middle, that's median. And then we have mode. What is mode? Mode means what? The number you see the most. So mean, median, mode, it's all of them, all three, they make up central of measure of central tendency. It means how do you measure the center of the data set? And if you observe the center, we have three scenarios. If mean equals median, mean, median, mode, they all are equal, we get a symmetric data set, a symmetric shape of our distribution. And if mean is the biggest one, and then median, and then mode, then we have skew to the right. So wherever we have the mean, that side is skewed. So when mean is the largest one, we're supposed to have the skew on the right. Because the skewness, the outlier takes your mean away. So if you have an outlier here, it will take your mean away. As a result, you get a skew on the right side. On the other hand, if mean is the smallest one, then you have a skew on the left, because if you have an outlier here, then the mean will be onto the left. So that's a T scenario. Symmetry, skew to the right, skew to the left. And then how do we know which one tells us the better explanation of the data or better description of the data? Well, if we have symmetric distribution, if you take either mean or median, they'll give the same result. But except for symmetry, for any other cases, the mode is actually tells us the not the mode, sorry, the median tells us the better explanation of the data. So if we have any outlier or if we have any distribution that is to the left or right, then instead of observing the middle, observing the mean, if you observe the middle, you'll get more information about your data set. Well, one example. We have a salary for a bunch of players. Who are these players? Which game they play? Anybody else? Basketball, true. So we have the salary for basketball player. So we have 34,000, 25,000. These are in million, okay? 34,000 million, whatever, it's a big number. Okay? So these are the salaries. And we calculated two things. What's the median and what's the average? So the average came out to be 8 million. And median comes out to be 2 million. Now, by observing all the data sets, which one tells us better information about the salary of basketball player? The mean or the median? Observe most of them are around here, right? We have 34 million, which is the highest one. Not many people get 34 million. So if you plot all these millions in a dot plot, then you see we have an outlier on the right, and then 25 is kind of outlier, but bunch of data, they are lying between 0 and 5. And observe our median, it's 2. Look at 2, we have the most. So if anyone asks what's the salary for normal basketball player, you cannot say it is 34 million. No, 34 million is not for everyone. Or you cannot say it's 25 million. Or you cannot say it's 8 million. No, those 8 million, 35 million, 25 millions, not everybody gets that much money by playing basketball. What most people get is actually around 0 to 5 million. So if you say, well, it's around 4 million, it makes sense. 2 million is still a lot, right? You guys should play basketball a lot. Be there. You don't have to waste your time. Okay, now math. I want everyone to participate in the math, okay? We're going to calculate mean, median, mode. Okay, guys? Okay. For mean, how do you find mean? What do you do? Add them divided by how many? How many we have? 1, 2, 3, 4, 5, 6. So our average is 159 through 126 divided by 6. What do we have? It's okay, take your time. What do you have? 14877. Is this correct? Do all of you have it? Great. You should all try, because just because you know something, it doesn't mean you're gonna get it. Trust me, from my experience with my previous students, they know everything in class, they know everything great. But when it comes to the calculator, they couldn't figure out simple average. Right? Maybe something is wrong. Maybe they added and then put the division sign at the same time. Calculator is very sensitive. You have to give them order of operation correctly. Okay, next you're gonna find median. Tell me the step. How do you start finding median? Do you start right away, or do you have to do something fast? Or diagram, right? So what do we have? The first number. 123.99. Next number. 126. 127.65. 157. 159. 199. 1. We have this two good that tells us our median is add them divided by 2. 142.325, which is 142.32. I'm keeping 2 places because all the data, they have 2 places after this. Great. Any questions so far? Okay, that's how I find median. And now the last thing, mode. Who wants to tell me the mode? UAD median. Let's give someone else. Go ahead. If you don't see one number more than once, what is your mode? All of them or none of them? You have to have at least more than once in order to be a mode. So we actually don't have any mode. It's none. Multiple modes allowed, but all numbers are not allowed. Unless all of them are more than once, which is rare. Okay, how are these values compared to one another? It means observe mean, median, mode. What do you notice? Do you notice anything? They're almost like the same range, but you can tell is a little bit higher. So I guess we can say that if they're higher, it would be more higher side. Do we have any outlier? We have 123, 126, they're close. 26, 27 close. 27 to 57, a little bit higher. 57, 59 close. But 59 to 99, what is happening there? It's a huge gap, right? 40 units there, right? 40? No. So we do have an outlier in this case. So which one gives us better explanation, better representation?
I would say median because
Exactly. The mean, if you calculate the mean without this, definitely it will be lower and closer to all the other numbers. So in this case, median gives us a better description of the data set. Any questions? So I plan to give one of these in the exam. Find mean, median, mode, range. Given a long range leader. Okay, and then I have the answer, but you already did everything. And now talking about variability of the data set. Variability means how spread out our data set is. For example, in the last one, we had from 123 to 199. So it was spread out very high, right? Throughout the entire number line from 120 to 200. So it has a very large variability. Variability describes how far apart data points lie from each other and from the center of the distribution. It refers to how spread out the data set is, blah, blah, blah. And then let's look at some examples. In the first example, we have 20 to 70, and they all have the same distance between them. So if you observe, we have our data set lying from here to there. So you have a large variability. The second example is running from 47 to 70. And we have two outliers. Most of them are in the middle. But still, our variability is from here to there. We still have a large variability in the data set. And then the last one, 44 to 46. All these numbers, they are very close to one another. So we have very less variability. Means our data set is very less spread out compared to the first one and second one. Range is from highest to the lowest, but variability, like how they are spread out from the center. There's a lot of variability in the first one. Second one has less variability compared to the first one, but the last one has the smallest variability. So we can talk about variability using four things. One is the range, then inner quartile range, then variance, and then standard deviation. So this could be a multiple choice question in the exam. Which of the following describe the variability? And then I'll give you one from here and three from somewhere else. So you have to identify which of these from the four options I'll give you is from this four. So range, inner quartile range, variance, standard deviation. These four things tells us how spread out our data set is, either from the center or throughout the entire number line. So exam multiple choice. So first one, range. Range is the difference between the smallest to the largest. So the largest number minus smallest number, whatever we have, that's the range. And range is always, if you have a large data set, then our range is bigger. Let's become an example. 30, 40, 50, 20, 70. What's the range? How do you know?
The largest number in this data set is 70, smallest one is 20. That's it.
Perfect. That means you have to identify what is the smallest one, what is the largest one. Just because you see 30 in the front and then 70 in the back, it doesn't mean 70 minus 30. 30 is not the smallest one, 20 is. Okay, how about the next one? What did you do? See, a huge range we have. So even though we have, these numbers, they are really far from one another. We have 40, and then suddenly 260, and then 300, 550, 920. They're all over the places, from 100 to, from 40 to 1,000. So we have a large variability in the data set. Okay, inner quartile range. In descriptive statistic, the inner quartile range tells us the spread of the middle half of the distribution. So to find the inner quartile range, we take the upper quartile and we subtract the lower quartile. What is quartile? It's like we have 0, 25%, 50%, 75%, 100%. Okay, 50% gives us the middle. For anything, 50% means middle. So lower quartile means middle half. So what's the middle of 0 and 250? 25. And then upper quartile means the middle of the upper half. So middle of 50 and 100, 75. So 75% minus 25%, that difference is the inner quartile range. It means the difference in the middle quartile. So for every number, we have different quartiles on the upper quartile and on the lower quartile. So we figure them out just like we figure out the median. We find the upper middle and the lower middle. We subtract smaller one from the bigger one. That's the range. So that's the inner quartile range. So you have to find them. Just like finding the middle, first you have to arrange them in increasing or decreasing order. We also have to arrange our data set from increasing to decreasing or decreasing to increasing, and then keep taking middle. First you take the middle, and then you take the middle of the middle, and then again you take middle of the middle. Okay, so you take middle 3 times, and we follow the same rule. If you have odd numbers, exactly middle number is the middle. But if you have even numbers, the average of the middle 2 is the middle. Anything else? The value of the inner quartile range does not affect by a few extreme values in the data set. Okay. So in the homework, actually there are some examples you'll see with visualization, like they have scatter plot and not scatter plot, 5-number summary, and then you'll see that they have some extreme values outlier, but we actually don't include them in our 5-number summary. So 5-number summary includes the inner quartile range. So that's why inner quartile range, it doesn't affect by the extreme values. So box plot. In a box plot, we use 5-number summary. What is 5-number summary? It's the minimum number, maximum number, and then the 3 middle. The first middle, the real middle, and then the upper middle. So minimum, quartile 1, median, quartile 3, and maximum. Quartile 1 means lower quartile. Quartile 3 means upper quartile. So using this formula, we get our 5-number summary. And this is just a histogram. I mean, a curve that tells us all the information. So if you divide your data set into 4 pieces, every piece gets 25%. The first one is 25, then 50, then 75, then 100. Okay, so we have a bunch of data sets. They are in order. Oh, so you don't have to order them. So this is the median for us. The median is the middle 2, average of the middle 2. Okay, let me show you. So to find the middle, the best way I said, I like to cancel 1 from the left, 1 from the right. Keep canceling 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. And then you're left to 2 numbers. So our real middle is the average of those 2. But now we see we have even numbers in our data set. So when you have even numbers and our middle has 2 numbers, to calculate the lower quartile, we have to include one of them from the middle on the lower side and include the other number from the middle to calculate the upper side. So the middle 2 numbers, we have to divide them. 1 goes to the lower quartile to calculate the lower quartile, and 1 goes to the other one to calculate the upper quartile. If you have 2 numbers in the middle, you have to split them when you calculate quartile 1 and quartile 3. So quartile, to calculate the lower quartile, we are going to observe the upper row. And we are going to do the same thing again. Cancel 1, 1, 2, 2, 3, 3, 4, 4. And again, you have 2 middle. So we take the average of the 2 middle, we get our lower quartile. And then to find the upper quartile, we do the same thing. we take 1 from the real middle. So this is our first term for our upper quartile. And then 1 here, 2, 2, 3, 3, 4, 4. We end up getting again 2 numbers in the middle. We take the average, that is our upper quartile. So when you have 2 numbers is always kind of complicated. For normal middle, that's average. For normal middle, we average them. For lower middle, take the left number from the middle, include that to calculate the lower quartile. Take the upper number, include that in the upper data set to calculate the upper quartile. But if you have odd number and 1 middle, you just cross that out and then you use the left for the calculate the left middle, and you only observe the upper side to calculate the upper middle. Okay. For odd number, it's easy. For even number, you just split them. So we have middle, lower quartile, upper quartile. What is our IQR? Means inner quartile range. What did you do? Upper quartile minus lower quartile. 6150. And then what do we have? 26. So it's telling us that all the middle have, they are spread out 26,000 units. Okay, your turn. Find everything with this data set. Can you see it? Question?
Yeah, saying that I'm not like able to log in. I can't like log in.
Is it down today?
If anyone has a problem.
Did any of you log into Blackboard or Fast?
Yeah.
You guys didn't have any problem?
I think you're-
Oh, so yeah. Probably you're not connected with the Wi-Fi?
I'm gonna try to get some.
Okay. Oh, let me take attendance now. Did you see today's date? 9/9. It's a cool day, 9/9. Alison? Daniel? No. Elisi? Yasmin? Ryan? Janae? Anton? Christina? Dirimichi? Christopher? Miyako? How do you pronounce it, Alison? Miyako, right? No. Ramesh? Jamina? Jamina. Huiting? Huiting. Xian? Tao? Sitao. Is it C or Sai? Tao, only Tao? Okay. Laila? Jason? Yusuf? Christabella, Nithya, Kevin, Salma, Keith, Karina, Maria, Mia, Tahmina here, Wendy, Sebastian, Fatima, Avanov. Is it A or A? Avanov. Queenie, Jason Joe. So Jason Joe is here. Jason Lou. No. Okay, are you guys done? Okay, I'll take volunteers, okay? Avanov, you tell me the numbers in order. No, 0, 0. Tell me the data set in increasing order.
Oh.
How many zeros we have? 1, 2, 3, 4, 5, 6, 7. And then 59, 71. If he skips anything, feel free to. You can see. Okay. Let's see. Town. Complete the set. So 83, 106, 130, 142. How many times? Twice. Mm-hmm. 189, 189. 21, 212, 224. That's it. Is it correct? Is 3 more piece or 3 missing? 306. Oh, okay. 349. 329.
36. 36.
Okay, 236 twice and then 306. See, that's right. You should all try. Just because you see something doesn't mean you can do it. We all should try so that you can see, you can feel how to work with data set. So is my data set correct? Did I order them correctly? Anybody does not have this. It's correct, right? It's perfect. Great. Then we are going to find Jannah. Middle. What is the median? So 130 and 142 here. Okay, so median 130, 142, take half. Is she correct? Is it, did you find it correctly? 30 and 42? No? Confusing? No problem, let's check. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. How many zeros we have? 6 or 7? 7, okay. So 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12,
Just one second.
There's just one.
12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh yeah, we have add many data set. So actually, our middle is this one. Because all of them cancel out except for 142. Am I doing it correctly, guys? Yeah. Okay. So 142. And since we have admin data set, that means to find the middle, we are going to completely ignore this. And we start going to count the lower side. Okay, let's see. Nitya. 0. So lower quartile is 0. Let's see. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Oh, we have 2 in the middle. So half of 0 is 0. Perfect. Let's see. Kevin.
For upper, it's 145.
145. Upper quartile 145. So let's check again. Let me change the color. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And we have this in the middle. So 189 plus 201. Take the average. I forgot, what did you say? Say it again. 145. 145 doesn't make sense. One, how much? 99? 95. You see? 195. Did we cross that correctly? So we have 89 and 201. They add up to 390. 195. Yep. Okay. So you see, when we have odd number, we completely ignore the middle one. The lower data set gives us lower quartile. The upper remaining data set gives us upper quartile. Compared to when we have 2 middle. When we have 2 middle, we cannot ignore any number. We're gonna take the smaller number to calculate the lower half, and we take the upper number to calculate the upper half. The way I did it. So this will be in the exam. Either odd or even, I don't know. But one of these. I did not calculate inner quartile range. I forgot. So let's see. Ulysses. What is IQR? Inner quartile range. What do you do? What minus what? Hmm? 195 minus 0. So upper quartile minus lower quartile. That is the inner quartile range. Explain why the lower quartile is the minimum value. Will it always be the case for every scenario? What do you think? No, right? Of course not. It's just a coincidence. Why this coincidence happened? See, we have so many zeros. That's why our lower quartile and minimum is the same number.
Okay, but do we have to like put them in order first?
Anytime you're working with middle, it means you need to put them in order. So the upper quartile means upper middle. Lower quartile means lower middle. That's why I need to put them in order. Okay, so we know what is range, we know what is inner quartile range, and now what is variance and standard deviation. The most common measure of variability describes the extent to which the sample observations deviate from the sample mean. So we want to see how our data set is different or away from the mean or around the mean. And we can calculate that by looking at the variance. And if you take the square root of the variance, we get the standard deviation. That's why the variance has a formula that from every observation, we subtract the average. So this variance, we take every observation from them, we subtract our average. Then the difference, we square them. And then we take sum of all the differences, and then we divide by 1 unit less than how many data sets we have. Whatever we get, that is our variance. And then to the square root, so we get standard deviation. You may wonder why standard deviation is the square root of the variance. Well, that's because in variance, since you're squaring our unit, squaring our data set, that means we're squaring the unit. For example, our data set is based on the age, based on the height of my students. So obviously it should be in inches, right? Foot and inches. 5'6" or 5'2". When you square, it becomes square inches. So it cannot actually work with two different units. That's why variance make our unit square. Since we don't like square because our original data set is based on only inches, so in order to get back to our original unit, we take the square root. That's how we get the standard deviation. So you get the same result. The standard deviation is just a smaller unit than the variance. And since we have two different things, sample and population, so we use two different notations. For sample variance, it's S squared. For population variance, it's sigma squared. For sample standard deviation is small s. Population standard deviation is only sigma without the square. Variance is a method to find or obtain the measure between the variables, that how are they different from one another, whereas standard deviation shows us how the data set or the variables differ from the mean, and the average value of the data set. So standard deviation works with original data set, where variance works with the square of the data set. All these details you can ignore. Blah, 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 blah. Anything important? No. Variance. We have two scenarios. When you're working with population variance, our denominator is the population size. But when you're working with the sample variance, our denominator is 1 unit less than the sample size. Okay, so there are two differences. In some books, if you read any statistic books, you'll see that when they calculate variance, they use different formulas. So you may wonder what they're talking about. Well, if you see your denominator is big N, it means they're working with population. If you see it's N-1 on the denominator, it means they're working with sample. That's how we can distinguish sample from population. Let's do some example. We have a bunch of data sets, and our goal is to find variance and standard deviation. Good news, we don't have to order them. We ordered them only when we work with middle. Variance doesn't need any middle, it needs average. So what is our first step? What do we have to find? Any idea? Calculate the mean. See your formula? We need the mean. So x bar. Jason, how do we find x bar for anything? For example, how do you find the average? Add the data set together divided by the number of data sets. So 29 plus 62, blah, 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 all the way to 49. Divided by what? Nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. We have 9 elements in our data set. So you're going to add them divided by 9. Okay, go ahead, try it. And then I'll take my volunteer. Understandable readers. But we also ask us to find population is a big number. Usually we don't know its size. Queenie, what's the answer? Louder, please. 52.11. Is it correct? Do all of you have the same thing? Good job. Once we find the average, the next thing we need is from every observation, we are going to subtract the mean and then square the differences. So it's better if you can use a table. In the first table, we are going to write all the x values, means all of our observation, like 29, 62, 37, 41, 70, 82, 47, 52, 49. These are all the x observation. In the next column is x minus x bar. It means we are going to subtract our mean from each of them. And then lastly, whatever we get, we are going to square the unit. So the first column is for the observation. Second one is the difference between observation and mean. And the third one is the square of the differences. So let's do one together. We have 29 minus 52.11. Did any of you calculate that already? What do we have? 28 points. Oh, 22, my bad. 23.11. That means in the next one, we are going to do 23.11 square. Yes, because 53 is minus. But if you square it, it becomes positive anyway. Do you know if you did the square already? What do you have? 534.07. Okay, now all of you try the rest. You don't have to write them down. If you already understand what to do, just punch a calculator and write the numbers down in log. And then at the end, we are going to add all of these. This means sum. It depends on the direction or on the data set. So if the data set doesn't have any decimal places, that means I'll tell you how many places. So in class, 2 or 3 digits is fine. Ready? Alison, the first one, the second one. Let me write this down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So Alison, second one. What do you have for x minus x bar? You're Alison, right? So 62 minus 52.11. Okay. So Kevin, you already did that. You guys did that. Danielle. Oh no, Danielle is not here. Yasmin. Second one. What do you have for the second row? 9.89 and square is 97.88.
No, 971.
Oh, 81. Okay. Sorry. Ryan, the next one.
37 minus.
Negative 15.11 and square 0.31. Perfect. Anton. Negative 11.11 and square 43. If I get something wrong, please teach me right away. Okay? Christina. Oh, you already did that. Never mind. Go ahead. The next one. Mm-hmm. 17.89 and square. Say it again. I didn't catch it. 320.05. Bilimichi, you're next. 82.
Okay. 82 minus 20. That's 39.89.
29.89 square. 893. 4121. Okay. So 41. Christopher. Sorry, absent. Niako. You're next. 47. Negative 5.11. 26 points. Correct? Okay. Noor. Negative 0.11. 0.01. It's 49, my bad. Thank you. Sorry. Ravi's.
So that kind of messed me up, but for the x minus it's -3. Squared.
Great.
Oh wait. No, sorry. -3.
49, 50, 51, 52. So 3 and the 3 square is 9. 2 is correct. Oh, no. It's 52.11. Yeah, so negative 2 point, right? 3.11. Perfect. And then the square? 9.67. Ah, we did it correct. I mean, we did it perfectly, right? Now, all of you add down. Oh, you guys already did that. You already did that? Okay. Jamina. Wait, Jamina. Shian. What's the sum? Shian? What's the sum? 2, 2, 3, 2, 8, 8, and the next number? 8. So it's 2, 2, 2, 2, 3, 2.89. Since all of our data set is in 2 places, let's keep our 2 places. So we found the sum. James, please? No. So let's do it here. Standard deviation, let me write this here. 52.11. So standard deviation is sum of all the x minus x bar squared divided by n minus 1, right? So we found the sum to be 2232.89. We're going to divide by what? 8. Perfect. What do we have? Lila. Okay. No problem. Take your time, miss. Even though you don't have much time. Now ready? Ready, Mila? 279. Any decimal? 0.11. Is it correct? Yes? Great. Now, how do you find standard deviation? Even though the symbol for standard deviation is always the S, but I personally like to write SD, so I can actually feel, I can see a standard deviation. That is actually small s. Okay? So how do you find standard deviation? Square root of the variance. That means square root of 279.11. It's n minus 1. For sample, it's 1 less than the sample size. But for population, it's the original population size. Okay. Christabella, what is standard deviation? Two 79.11. Another square root. 60 points or 16. 16.7 and then next digit 0. 0 after 0 what do we have? 06. So 16.71. Is it correct? Wonderful.
You round first and then hit the square, like switching the square root over, like. If you can just.
Actually, if you want to get the accurate result, don't round anything. Once you get this, try to have as many places as possible, and then divide it by this, and then take the square root.
On the example, for all, let's say we do round it with the and stuff. We use one like slightly off for all.
No, I don't think. Unless it's a huge difference. For example, something at 279, let's say you got 276. 3 units difference, a huge difference in a month. Or if you have 379, this is wrong. So if you have some difference here or in the first digit, I understand. It's a little bit off than the actual one. But if you're way off, then something is wrong. Okay, so exam. Either you'll have it in this exam or in the final, but definitely you'll see this at least in one exam. But good news, I'm going to give you small data set to work with, probably with 4 numbers or 5 numbers. So you don't have to spend much time on it. Any question on the standard deviation or variance? Huh? If a very expensive cheese, I mean, all of these are, I did not read the direction, I just went for the math, but it says it's the cost for cheese, Swiss cheese, okay? Now it says if you add a very high price, what will happen to the mean and standard deviation?
I was gonna ask, are you gonna put sample deviation or are you gonna put both sample and population?
Population, we have no idea. So in this class, we're going to work with sample. But in your life, if you work in statistics, if you ever work in a stat field, probably you're going to work with population. But this is a basic class, so we all have sample only. So what do you think? So basically it's saying that all of these are price in stems. So this is 29 cents, 62 cents, 49 cents. And if you add 150 cents here, how that expensive price change the mean and standard deviation? What do you think? The mean definitely will not be 52 anymore, right? It will be higher than 52. And because our mean is getting higher, as a result, the variance will get higher. Since variance will get higher, obviously standard deviation will get higher. So we are going to get some information that is kind of not close to the actual data. It's kind of away from the actual data. So scoot to the right side. Good. So it will increase. And we have 16 to 79, 52. 16 to 79, 52. Perfect. Okay, now box plot and whisker plot. So box and whisker plot. Box and whisker plot, it includes 5 numbers, like I said before. And in the 5 number, we have minimum, maximum, and then the middle 3. So how do you draw them? We first find all the information, minimum, maximum, 3 middle. We put them in the number line. And then for the middle 3, we put a bar, we connect them with a box. So that is our box. From the box, the smallest number, we put a whisker, and to the largest number, we put another whisker. So we get whisker and box plot. So box and whisker plot that tells us how much of the information we have in the middle. and what is the minimum and what is the maximum number. So if you have your middle is exactly in the middle, that means it's a symmetric distribution. But if you have your middle is on the low side, that means you have pull to the right. And if you have your middle toward the right side, you screw on the left side. And we have, if you have an outlier, we just ignore the outlier. We don't include them as maximum or minimum. Unfortunately, I don't have any example in this class with the outlier, but in homework, I noticed there is at least one of them with an outlier. In the exam, I'm not going to give you anything with the outlier. Okay. One example. Find the 5-member summary and make the box and whisker plots. This is one of my favorites. It doesn't need any math, it's just simple. Okay, go ahead, try it. We have 1, 2, 3, 4, 5, 6, 7 numbers. We need to find out its maximum, minimum, lower quartile, upper quartile, median, and also it doesn't say it, but we can also find inner quartile range. What do you think is our first step? Any guess? Great. Anytime you're working with median, means you have to order them. So any volunteer for ordering the set? 0, 6, 9, 11, 18. Oh, 14 first, right? 13, 14, 18. Great. What's the minimum? 0. We don't need any math. It's simple. Minimum is 0. What's the maximum? 18. Now, what's the median? Which one? 10.14. So to find the middle, we're going to cancel one from the left, one from the right. Okay? So 1, 1, 2, 2, 3, 3. And we only one number in the middle. That tells us our median is 11. Okay, who wants to do lower quartile?
Because we have a
Mm-hmm.
we could just grab something here. So it's like at the so I think it's 6.
So there they cancel out. We have lower quartile. Lower quartile is 6. Go ahead. Do the upper one. 14. We do the same thing. Cancel, cancel. We left with the middle 14.
Right.
No. It cannot cross out. Instead, you take the smaller one and include that to calculate the middle, the lower quartile. You take the bigger one to calculate the bigger quartile. We only cross out if you have one number. Okay, so since you're doing this IQ1, what is our IQ1 here? Volunteer? 8. So upper quartile minus lower quartile, 14 minus 6 is 8. Perfect. Now let's do box and whisker plot. I want you to draw them scaled. It means as accurate as possible. Otherwise, the information you get could be wrong. So we have 0 to 18. Let's divide them into two pieces. I mean, by two pieces. So 2, 4, 6, 8, 10, 12. That's too much. I have to make it smaller. 2, 4, 6, 8, 10, 12, 14, 16, 18. So to draw, first plot the minimum and put a dot on above that. So 0 is minimum, 18 is maximum. Put another dot above 18. And then we have 6, 11, 14. On 6, you're going to draw a vertical line, 11 in the middle, a vertical line, and we have 14, another vertical line. We connect all the vertical lines to make a box. So that is our middle information, lower quartile, median, upper quartile, 6, 11, 14. This is 0, this is 18. And then just put a line from the back to the minimum and the maximum. If you draw it as scaled, you can see which type of distribution you have. What type of distribution you have? Symmetric or skew to which side? To the left, right? Because our median is on the upper side. So we have something like this. The left side is good. The right side is going straight down. Skew to the left distribution. So in the exam, you're going to do 5-number summary, IQR, bus and stuff. No, you're going to draw the number line. And if you don't do as scaled, you're going to lose 1 point. The total is only for the bus and whisker, it's 2 points. If you don't make it scaled, it's only 1 point for you. Right. It doesn't have to be perfect. But see, if you draw it as accurately as possible, you can see the squareness. Okay, that's all for today. In our Wednesday's online class, we're gonna actually I'm gonna skip this. It's too much. We're gonna work with the next example. And I have posted the slides on Blackboard, so you can skip that. Once you're done in chapter 4, we're going to go to chapter 6, which is probability. So most likely tomorrow we are going to start chapter 6. If we are done with this. So goodbye everyone. Have a good day. Chapter 5 will be the last chapter for us. The homework is on 20th of Sunday. 20th of Sunday.
Like for you, probably you
All
get
past homework due is 15.
no, I know. Like, for some homeworks that will leave. I noticed that there's some topics like this covering the homework that's not applied for the lecture.
Yeah,
Are we?
these are from book.
You're not gonna put those in the.
The lower quartile is the 25% information. Okay? So it's the middle half. So first you find the middle. To find the middle, you just cross out one from the left, one from the right. At the end, whatever remains, that is your middle. So if you add many numbers, you cancel one left, one right, one left, one right. You have only one middle. But if you have even many numbers, You cancel one left, one right, you have two in the middle. When you have two in the middle, your median is average of them. So you add them, take the divided by 2. So in this case, we have add many numbers. After you cancel one from the left, one from the right, we have 11 in the middle. That's our median. If you have one number in the middle, then you cancel them out, and then you take the remaining numbers, and calculate the middle again. So you cancel one from the left, one from the right. Keep canceling them until you go to your middle. Again, if the middle is one number, that's your median. If it's two number, take the average.
So it's almost like the same thing.
Same thing, but we do it 3 times. One is with the whole data set. Once we split the data set into 2 pieces, after finding the middle, then we do them again, one from the lower side, one from the upper side. So this is what we do when we have odd number in the middle. But let's see if even number in the middle. So let's say have 1, 2, 3, 4, 5, 6, 7, 8. 8 number. So cancel 1, 1, 1, 1, 1, 1. You left it 2 in the middle. If you left it 2 in the middle, you cannot cancel them. You take the average, you get the median. Once you get the median, then you take the lower side, the number from the lower side, and you include in the lower data set. And then you calculate again. Cancel, let me change the color. Cancel, cancel, and you have this, so you take the average to get the lower quartile.
Okay, now
And then you still have another number left in the real middle, right? So you include this for the upper data set. And you do the same thing again. You cancel, cancel, you left with the middle, you take the average, that's upper quartile.
and then we got it in profile.
Mhm.
Thank you so much.
So this lower quartile tells us how much you have for 25% of information. The middle tells us how much we have in the middle to 50%. And this is the 75%. How much you have for 75% information.
Thanks so much.
No problem.
Have a good day.
You too.
So I'm a little confused, like how is it?
Because you see, you have a huge difference from middle to the smallest number. Right?
Okay.
Compare with this difference. So since there's a huge difference here, that means go to the left.
Okay, so whichever side has like 4 differences.
So it's that side.
Okay. And for the exam, you know, like do we have, are we gonna have to like explain this to you? Like,
You don't have to explain. You can simply say whether it's go to the left or it's go to the right. So I'm going to ask you which type of distribution uses symmetry. It's go to the left, it's go to the right.
so most likely like a multiple choice question.
Yeah, this will be multiple choice, but the rest is not. The
Okay.
rest is you have to do the work.
Yeah.
Mm.
Alright, thank you.
So, recently I was thinking about dropping class because I did all science courses this semester. So I just wanted to make sure I was better at them. But I'm actually considering keeping it. I like teaching stuff and stuff.
Thank you.
So I didn't really take a look at the website with like any assignments that you posted. So are there like, is there anything that I missed or?
They all are open, so you can go ahead and do them.
Sure.
We covered so far chapter 1 to 3. This is chapter 4. So for chapter 1 to 3, most of them are multiple choice. It's on website. And all you have to do is click, 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 you get the answer right.
Okay.
And the math starts on chapter 4, where you really have to do the math.
But I didn't miss any assignments for now, right? When's the next meeting? Just so I have.
Chapter 1, 2, 3, 4, they do on 15th. And then for the rest, it's the entire semester.
All right, thank you. Take care.